Hi everyone, my name is Muhammad Sifal Mufid. I'm a PhD student at Department of Computer Science, University of Oxford. In this ConcurB conference, I will present my recent work titled SMT-based model checking of max plus linear system. This work proposes the novel procedures to solve formal verification over max plus linear system, the class of discrete event system defined over max plus algebra. The other authors of this work are my supervisor Alessandro Abate and also Andrea Micheli and Alessandro Cimati of Fondazione Bruno Kessler, Italy.
So this talks about program logics, specifically decidability issues on program logics like the model mu calculus or propositional dynamic logic. Now the situation as we know it is there are basically two maximal decidable program logics, the model mu calculus and propositional dynamic logics over visibly pushdown languages. So the question is, since they are incomparable in expressive power, isn't it something we can construct that subsumes both of them and is still decidable? So something in the space here. And the answer to this is yes. And in order to do this, we need to look at a common superlogic, namely fixed point logic with ConcurB. Now, the story goes back quite a while ago to ConcurB 2002, where this handsome looking young man gave a characterization in terms of games for the model checking problem for fixed point logic with ConcurB. And we can use this now to construct satisfiability games for this logic, even though the logic is undecidable. So by looking hard at these satisfiability games, we can carve out a fragment of this logic, which we call visibly pushdown fixed point logic with ConcurB, such that the satisfiability games corresponding to this fragment are actually stair parity games, and they are decidable. And this is how we get a new maximal decidable program logic, which is actually more expressive than the two others that we've known so far.
Hi everyone, and welcome to this short talk about the temporal logic for strategic hyperproperties. So, what's our work about? Well, on the one hand, we have hyperproperties. These are properties that refer to multiple traces in a system and are commonly used, for example, in the information flow control, where we want to express properties such as non-interference. And on the other hand, we have multi-agent systems, where we usually talk about the strategic behavior of a group of agents within this system. Now, unfortunately, none of the existing hyperlogics can express meaningful properties in these multi-agent systems. So what we do in our paper is we propose a new logic called hyper-ATL star that can do just that. So we can reason about hyperproperties with respect to the strategic behavior in such a system. What we do in the paper then is study various properties of our logic. For once, we show that it is very expressive, subsuming both existing hyperlogics such as hyper-LTL and existing logics for reason about multi-agent systems. We show that it is useful for expressing various security properties such as simulation-based security or non-deducibility of strategies. We also show that it is very useful for expressing asynchronous hyperproperties, so properties where the systems do not progress in a synchronous manner. Despite its expressivity, we show that model checking our logic is still decidable, and we give tight upper and lower bounds on this problem. And last but not least, we've evaluated a prototype model checker that can check a fragment of our logic on concurrent game structures and evaluated it on various small properties. So if you're interested in that, please have a look at our paper.